Hello student, good morning. I am Dr. K.SINHA, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing electrochemistry. Actually I am reviewing the electrochemistry. Then up to question number 30, up to the 35 points I have discussed. Actually all important points I am discussing. Then next point I am discussing electrode potential. What is electrode potential? Already I have given brief idea in the last class. Now I will discuss a little more. Electrode potential is the tendency of an electrode to lose or gain electrons when it is in contact with the solution of its own ion. The tendency to lose electron is called oxidation potential, whereas the tendency to gain the electron is called reduction potential. Here tendency is important. Electrode potential is the tendency of an electrode to lose or gain electrons when it is in contact with the solution having its own ion. The tendency to lose electron is called oxidation. The tendency to lose electron is called actually processes of the oxidation, and due to the tendency, that oxidation is called oxidation potential. The tendency to lose electron is called oxidation potential because it processes oxidation. Similarly, tendency to gain the electron is called reduction potential. Gain of electron is reduction, process is reduction, and potential developed in this process is called reduction potential. If standard conditions are used, that is a temperature 298 Kelvin, concentration 1 m and pressure 1 atmospheric pressure, the electrode's potential is called standard reduction potential. Now next point is absolute value of electrode potential. Absolute value of electrode potential. This cannot be determined. Why? Because oxidation or reduction half reaction cannot occur alone. Moreover, a reference electrode is required. What is the reference electrode? Then normal hydrogen electrode, also called a standard hydrogen electrode or normal hydrogen electrode, NHE, and standard, if it is a standard, then is called a standard hydrogen electrode, SHE. Okay, NHE or SHE. It's how it is made, then in diagram you can understand by the diagram. Here what you will find that here platinum wire is used and hydrogen gas is passed. See the diagram, you can understand. Here platinum wire is used and hydrogen gas will be passed, and mercury foil will be there at the you can say end. End means which is dipping in the solution. Solution is of 1 mHCl, 1 molar hydrogen chloride solution, and after that one platinum foil will be there with mercury, which is will be at the end of the wire. Hg will be there. Through Hg platinum foil coated with platinum black is attached. Okay, and solution is of 1 m HCl. Then this is actually arrangement of hydrogen gas electrode or normal hydrogen electrode. Solution is of 1 m HCl, that is important, and hydrogen gas at 1 atmospheric pressure is passing. Then through the wire actually current will pass. When reaction will take place, then it will release the electron. Then that electron will be passed through the, you can say, wire. And that electron again with further connection with ammeter, we can measure the conductivity or current. Then now actually how this electrode is represented? Then it is represented, actually you have to give importance for three things. First, here platinum is electrode, PT, and after that hydrogen gas what you are passing, that is its pressure is 1 atm. Hence platinum you have to write, after that hydrogen gas you have to write, and its pressure. Here pressure is 1 atm. And now after the reaction what will happen? It will produce a H plus electron. One hydrogen atom will produce, you can say, H plus and 1 electron. Correct? Then this H plus will be in the solution. An electron will through the platinum wire, it will pass through the you can say connecting wire. It will pass through the connecting wire or through the ammeter, and you can measure the current. Then it is represented like that: platinum / hydrogen gas pressure should write 1 atm / H plus, because H2 gas it produces H plus. It will in the solution. Actually it is dipped in the solution only, 1 m solution. That's why you are writing H plus. H plus you are writing because solution what you have taken, that is the 1 m. Then this hydrogen gas you have to mention, and its pressure you have to mention. Then you can represent it as a platinum / H2, in bracket you can write 1 atm, and after that H plus. What is the concentration of H plus? Then 1 m. This is a representation of a normal hydrogen electrode. Now what is the EMF, electromotive force? Then EMF, also called cell potential or cell voltage, is the difference between the electrode potential of two half cells. In the cell, two electrodes will be there. One will be anode, other will be cathode. Then during half cell reaction, at anode oxidation takes place, and at cathode reduction takes place. Correct? Then potential will develop at both, at anode and at cathode. Then what is the difference of potential between two electrodes? That is called cell potential or EMF, electromotive force, or cell potential. Correct? Three terms are there: EMF or cell potential or cell voltage. Three terms are there. Then EMF or cell potential or cell voltage is the difference between the electrode potential of two half cells. And how will you define EMF? EM is the potential difference between, again listen, important point I am telling you, EMF is the potential difference when no current is flowing in the circuit. Correct? Important point. It can be measured by potentiometric method only. EM is the potential difference when no current is flowing in the circuit. Okay? It can be measured by potentiometric method. Actually, current will flow only if you can say one side electrode potential is more and other electrode potential is less, then it will flow. Current will flow just like from high, water flows from high to low. Same way current flows until both becomes equal, means difference should be zero that time. Up to that level it will be flowing, and finally when potential will be equal both sides, then it will not flow. And suppose due to any reason where it was high that became low, and where it was low that became high, then direction will reverse. You know that flow of electron is called current, and direction of flow of ions, which is opposite to the flow of current. In solution, ions flows. Then upside from anode to cathode. Suppose anode has a high potential. Then electron will flow from anode to cathode. Electron will flow. But ion will flow through from the cathode to anode. Then like that way circuit will be completed. Correct? Then this point you should know that EMF is the potential difference when no current is flowing in the circuit, not between the 2 points of electrode. Correct? Complete circuit I am talking about. Then EM is the potential difference when no current is flowing in the circuit. It can be measured by potentiometric method only. Now I want to discuss about electrochemical series. Already I have given you idea last class. I briefed it all. Now I am telling you little more about the electrochemical series. Electrochemical series is the arrangement of electrodes in order of increasing standard electrode potential. That is the reduction potential. Electrochemical series is arranged. This arrangement is of actually different metal, or you can say electrodes. Electrochemical series is the arrangement of electrodes in the order of increasing standard electrode potential. Then here electrode potential is of reduction potential. Actually reduction potential is considered as a standard according to IUPAC. Okay, then this is arranged according to the reduction potential of electrodes, means from low to high via zero. And what is actually application of electrochemical series? Then there are actually 5 main application of electrochemical series. Many question is asked. Then one by one all 5 I will tell you. That is called actually application of electrochemical series. Use. What is the use of electrochemical series? Means arrangement of electrodes according to the reduction potential, low to high via zero. What is its application? Then now first application I am telling you. To predict the relative oxidizing and reducing power. This is the first application. To predict the relative oxidizing and reducing power. Greater the reduction potential, more easily the substance is reduced, and hence is a stronger oxidizing agent. Oxidizing power of halogens are in the order I am telling you. Fluorine is greater than chlorine, chlorine is greater than bromine, bromine is greater than iodine. Means this fluorine can attract electron very fast. After that, chlorine. After that, bromine. After that, iodine. Then here, by seeing the value, by seeing the reduction potential value, you can predict the relative oxidizing and reducing power. How? Then by seeing the value, greater the reduction potential. Greater the reduction potential means what? You are thinking about the metal. From non-metal to metal, actually it is arranged in real sense. Then more, if reduction potential value is more positive, it means they want more electron. Means it can oxidize. It can take electron from the other metal. Correct? Very fast it can take. Then that gain of electron is called reduction. Then more the positive value, more the oxidizing power. And for that, from that electrode which is giving the electron, then that is called reducing power. Means it is reducing, means it is giving electron. It is giving electron. If any metals are giving more fast electron, any metal, that it means reducing power is more. Correct? And who is taking the electron? Means reaction process. Then it is the taking electron, means from that atom A, suppose A to B, this you consider. Then A will lose, B will take. Then B is taking electron. Then due to this B only, oxidation is going on. Correct? Means for the reduction, it is gaining, B is gaining electron because A is losing. Then A is losing due to B. Then B is the oxidizing agent. Correct? B is oxidizing agent. If B was not there, then A can't lose the electron. Then this is actually process is reduction, gain of electron. Then this, and for the reduction, who is responsible? A is responsible. If A will be not there, then there is no question of reduction. Actually, both takes together simultaneously. One will lose, other will take. Then for the reduction, A is responsible. Then that is called reducing agent, opposite to each other. One is called oxidizing agent, means who is taking electron, that is called oxidizing agent. And those who are losing A, those who are losing, that is called reducing agent. Then how much they will can say reduce, that is called power of how much they are giving, A power and B power. Correct? Then means reduction power, oxidation power. Then B is taking electron. How much its power is there? That is called, this is actually oxidizing agent. Then this is called oxidizing power. And A is losing electron, that is called reducing power. Correct? Then by this value you can tell if it is a negative value, more negative, it means you are talking about the oxidation, it is losing, and B is taking, then that is called reducing power. Then here, greater the reduction potential, more easily the substance is reduced. Here you should understand, greater the reduction potential means positive value, means they want electron. More positive value means they want electron. Then greater the reduction potential. Correct? More easily the substance is reduced. Correct? Because their power is more. Greater the reduction power, Reduction potential means that A is losing. Now that is actually power reduction because it is reducing. It is reducing B. Then that is called reduction power. Then here greater the reduction potential, it means more positive we are talking about. Hence, more easily the substance is reduced, means they will take electron because they are hungry for electron, it will take. Correct? Then that is actually here only one point you will understand, other is the reverse way. Then greater the reduction potential, more positive value, more easily substance is reduced, and hence the you can tell in another way is a stronger oxidizing agent. Now due to this B, A is losing. Then now A is actually called this thing reducing agent, and B is called oxidizing. Correct? B is called oxidizing agent. Then this way you can understand very easily. Greater the reduction potential means power to give, means electron which can be, if any element is releasing electron fast, it means it will reduce fast. It will lose the electron fast. Then it is telling about reducing power. Who wants electron, it will gain the electron. Then it is reducing power. And reverse way, B is taking electron, then it is called oxidizing power. I think you have understood. Then in that way, this some value fluorine, chlorine, bromine, iodine, if you will compare, then you will find fluorine is most electronegative in entire periodic table, most electronegative value. Correct? Then here this if it wants electron, fluorine wants electron. Correct? Then in that sense oxidizing power, because also you can tell fluorine has electron. Correct? All four fluorine, chlorine, bromine, iodine, they have electron. Then oxidizing power, and all are electronegative, they want electron. All four want electron. The who want more? Then fluorine. Then fluorine is called because it will take electron very fast. That's why fluorine is fluorine means oxidizing power is more than chlorine. Then bromine is less and chlorine is more. Fluorine is more than chlorine, and chlorine is more than bromine, and bromine is more than iodine. And so you can write F2 is greater than Cl2, Cl2 is greater than bromine, bromine is greater than iodine in term of oxidizing power. Oxidizing power of fluorine is more than chlorine, and chlorine is more than bromine, and bromine is more than iodine. This is the first application. Second, to calculate the standard EMF of the cell. You can calculate by seeing the value. This standard EMF of the cell can be calculated because formula is there. Standard E cell is equal to standard electrode potential of right hand electrode minus standard electrode potential of left hand electrode. I have discussed actually cell representation. Then first is the anode and other is the cathode. Then first is called left hand side, other is called right hand side. Then right hand side minus left hand side. Okay, that is actually difference of potential. Hence standard E cell is equal to standard electrode potential of right hand side minus standard electrode potential of left hand side. Then all values you are knowing for left, because all metals it is arranged, and all metals value you are knowing. Then which one is right side, that potential you can write minus. Which electrode is left side, that value you can write. Then difference of both is called a standard cell. This is the second application. Third, to compare the relative activities of the metals. Which metal is more reactive, which metal is less reactive. That you can have idea. Okay, you can compare. How? Then I am telling you. Greater the oxidation potential, greater the oxidation potential of a metal, greater is the activity. Means which metal is losing electron fast, that is more reactive. Then actually this is arranged, electrochemical series is arranged according to the reduction potential. Correct? If you want to know oxidation potential, then only just to change the sign. Negative will become positive, positive will become negative. Correct? Then reduction potential, what is arranged, that is according to the reduction potential from the less to negative to positive via 0. You can compare in a negative also. Among negative only, which one is more negative? More negative reduction potential. Then it means more negative means more reactive. More reactive means whose potential is less, that can lose electron fast, and whose potential is more positive value, they can't lose. They want actually. There is no question of losing. Correct? Then this I told you that activity you can understand. Greater the oxidation potential, greater the oxidation potential. Just I am telling you example. Lithium is minus 3.05 volt. Minus 3.05. First you can say electrode. Its potential is very high. Reduction potential in negative minus 3.05. And gold, if you go, then it is somewhat last. Its value is in plus 1.38. 1.38. Then see where negative and where is positive. Then more negative reduction potential. More negative reduction potential means more reactive. Or if you will compare with just to reverse it complete, then minus will become plus, plus will become minus. Then in the term of oxidation potential, lithium potential will be positive, very high. Correct? But that is called oxidation potential. And gold in term of oxidation potential, that will be minus. That is the least. Then what I told you now, just greater the oxidation potential means plus 3.05. If you will compare with oxidation potential only, then it will be plus. Then greater the oxidation potential of metal, greater is the activity. Then in both way you can understand. Greater means in positive way also, lithium is only coming, and reduction way also, minus you are telling. Then the term of reduction, whose reduction value is very, very, you can say, less, minus 3.05. That anyone you remember, otherwise you will get confused. Whose reduction potential, whose value is negative, most negative, they will react fast. Activity will be more. Now this I will tell that some values you can understand which metal is more reactive. As a result, what I discussed now, as a result, a more active metal can displace a less active metal. This is again another point. A more reactive reaction is going on, then more reactive metal can displace less reactive metal from the salt solution. Then some example I am telling you which metal is more important. Then some common elements in order of their decreasing activity. Then potassium, just as for example, potassium is first, means more reactive than sodium. Then potassium coming in the beginning. Then potassium is, what example I am telling in that way, potassium is in the beginning most reactive, and auric is coming in the end, then least reactive. That's why people will use gold, because it can't react with air and water. Correct? Its shining will be as it is. Silver also. Then now I am telling potassium is more reactive than sodium. Sodium is more reactive than calcium. Calcium is more reactive than magnesium. Magnesium is more reactive than aluminum. Aluminum is more reactive than zinc. Zinc is more reactive than ferrous, iron. And iron is more reactive than nickel. Nickel is more reactive than lead. Lead is more reactive than H. H has actually zero potential. You remember, a hydrogen has simply arbitrarily it is given zero value without any reason. Okay, simply it was considered H standard electrode potential of hydrogen is considered as a 0. Correct? Then this I told you, lead is more reactive than hydrogen, and hydrogen is more reactive than copper. Actually, hydrogen onward, all metal reduction potential will become a 0, this positive value. Hydrogen onward, down, from up to down, then after the H, all metals will have a positive value. Their positive value will increase. Then H is 0, then copper is now positive value 0.34, and after that Hg, its value is 0.85. After that Ag will come. Correct? H is equal to 0, copper is equal to 0.34, and H is equal to 0.80, and silver is equal to 0.85 volt, and auric is plus 1.38 volt. Then see how their reduction potential slowly increased from minus to plus via 0. Then whose value reduction potential is a more negative, that will be more reactive. Then in potassium and sodium, potassium is coming above the sodium, then potassium is more reactive than sodium. Sodium is more reactive than calcium. Third position is calcium. After that magnesium, then calcium is more reactive than magnesium. After that aluminum is there, then magnesium is more reactive than aluminum. Like that way, aluminum is more reactive than zinc. Zinc is more reactive than ferrous. Ferrous is more reactive than, ferrous means iron I am talking about, nickel. And nickel is more reactive than lead. Correct? Then negative to slowly just decreased this negative value. Negative was more negative, now become less negative, and then 0. After the lead, it becomes 0 in case of hydrogen. After that, positivity value increased. Then beginning top, who are actually more negative, it means more reactive. Now fourth application, to predict the spontaneity of any redox reaction. If EMF of the cell is positive, means ER minus EL, right hand side, electrode potential of right hand side minus electrode potential of left hand side. If its value is positive, then you can tell reaction is spontaneous. Redox reaction is spontaneous, means by own it will take place. You have to not do anything. If you will mix two things, a reaction will take place. That is called spontaneous. Extra things you have to not do. Only you have to mix two things. Reaction will start. Sometimes if you will mix, reaction will not take place. You have to heat it. You have to put some catalyst, something. Then reaction will start. That is non-spontaneous. See, flowing water from top to bottom by own, that is a spontaneous. But water taken from down to up to the hill, how will you take? This is a very difficult task. From down to up, you want to take the water, then it is not easy. By only a machine, you can say, you have to spend the electricity, this, that. Then motor, you can say, by the use of motor only you can say from ground level to fourth floor you can send the water. That is a non-spontaneous, where you have to do some extra things. Then that is actually non-spontaneous. If suppose you are a great person and people are coming to meet you simply by their own, if you are giving, suppose anywhere lecture, then many person will come just to listen you. Without, simply you have not given anything, sir. Then that is called as spontaneous. Sometimes nowadays, that they will call the person, they will give some gift, money, this, that, food, lunch, then they are coming. That is non-spontaneous. Crowd is non-spontaneous. If by own persons are coming, that is spontaneous. Now, this I told about the prediction of a spontaneous reaction. Means to predict the spontaneity of any redox reaction. If EMF of the cell is positive, it is spontaneous, otherwise not. And last point, that is the application last point, to calculate the standard free energy change of the reaction. You can calculate by seeing the potential of electrochemical series. You can calculate the standard free energy change of the reaction. How? Then one relation is there. Minus delta G is equal to NF E cell, E standard cell. Then E standard cell you will come to know only by use of electrode potential, anode and cathode. Then E cell you will come to know. And when E cell you are knowing, a standard E cell, then in this formula, free energy minus delta G, free energy change, standard free energy change, that is equal to minus standard delta G value, that is equal to NFE. Then E value are knowing, F value is fixed, 96,500, N is equal to number of electron. Hence minus delta G, change in free energy, you can calculate, wherein N is the number of electrons involved and F is the farad. 1 farad means 96,500 coulomb. Its value is fixed. Then these are the applications of electrochemical series. Now I will discuss effect of concentration on electrode potential. If concentration will change, then how will it affect the electrode potential? Then for that I am telling you, actually always you write a reduction reaction. Reduction means metal ion plus electron, and it will convert to metal. That reaction you have to write. This is a reduction reaction. IUPAC considered reduction reaction as a standard. Correct? Then you should write in a general way. Suppose metal ion you don't know whether it is a one positive or two positive or three positive, don't know. Hence you write metal N plus, a small n plus, M you write upside a small n and plus. N may be 1, N may be 2, N may be 3, N may be 4 also. Then here Mn plus, same number of electron, when it will absorb, only then it will become neutron, metal. charge will be neutralized. If N positive is there, then it will neutralize. N electron will only neutralize. Then it will become charge free, means neutral, no charge. Means it will convert to metal, M. Correct? Then you can write always reaction like that. Mn plus N electron. Electron is negative charge, you know. That's why it will neutralize positive charge. Then Mn plus Ne. Product will be metal, capital M. Mn plus Ne minus, it will give metal. Okay, M solid. And now you can tell this Nernst equation you can apply. This reaction you have written, reduction reaction. Then on the basis of this reduction reaction, Nernst equation can be applied. Correct? Then you know that electrode potential, actually Nernst equation is for both, for electrode potential also and for E cell also. Okay, Nernst equation is applied for both to calculate single electrode potential as well as cell, this EMF of the cell. Then E electrode is equal to formula, you know, that Nernst equation formula, that is the E is equal to standard E minus 2.303 RT divided by NF log product by reactant, concentration of product divided by concentration of reactant. You remember 2.303 came because ln converted to log, that's why 2.303 came. Again I am telling you, E is equal to standard E, any time electrode potential, that is equal to E is equal to standard E minus 2.303 RT divided by NF. After that into log concentration of product divided by concentration of reactant. Then here in this case, metal, actually generally for solid or gas, its concentration is considered as 1. Then for the product which is solid, M, metal, that's why for that you can write 1 divided by metal ion concentration. You don't know, that you have to write. Then 1 divided by Mn, you write in bracket, big bracket, that is called molar concentration. Then now electrode potential you can calculate by this metal ion concentration. It depends upon metal ion concentration. Correct? Either it will increase or decrease depending upon this metal ion concentration. At 298 Kelvin, if temperature is 298, means 273 plus 25 degree, then R, and if suppose R value is fixed, you know, then if temperature is 298 Kelvin and R value you know, and after that N value suppose also you are knowing, suppose you are knowing maybe 1, 2, 3 anything, and F value also you are knowing, it is fixed. Then after putting all this value, then after solving you will get F value is fixed, R value is fixed, T value is already fixed at 298. N value depends upon the reaction, what type of reaction is there. N is equal to 1 or N is equal to 2, N is equal to 3. Sometimes reaction will be related to silver, then you will get only 1 electron will be involved. If calcium is involved, then 2 electron. If aluminum is involved, then 3 electron. Then N you don't know, that's why N you have to write. Then after solving all the things except N, its value will come 0.0591. 0.0591 after putting the value of R, T and F and multiply it by the 2.303. Then you will get 0.0591 divided by N. Then N and metal ion concentration. These two things, if you are knowing, If you know that n is variable, maybe 1, maybe 2, maybe 3, maybe 4 also. Metal ion concentration is also variable. Hence, electrode potential, standard electrode potential is fixed. Then electrode potential depend upon n, a small n, number of electron, and this metal ion. It also depends upon R and T. R value is fixed, T value may be variable, but generally 25 degree we are considering. Hence, mainly it depends upon a small n and metal ion. Now, effect of concentration on the EMF of the cell. Effect of concentration on the EMF of the cell. Now I have discussed effect of concentration on electrode potential. Now I am telling effect of concentration on the EMF of the cell. Then say reaction you can write that A plus B is equal to C plus D, or A plus B is equal to X plus Y. but you don't know how many A is there, how many moles of B is there, you don't know. How many X is there product, how many Y products are there, that you don't know. That's why simply it is written a small a into capital A plus a small b into capital B. Product side you can write x, a small x into capital X plus a small y into capital Y. Correct? In general way you can write, because these are the coefficients that will be changing according to the reaction. This is also called actually coefficient, stoichiometry. Then now on this reaction, for this reaction you can write the Nernst equation. I told you Nernst equation is applied for anode also and for cell also. Then in the place of electrode now you write E cell. E cell is equal to a standard E cell minus 2.302 minus 2.303 RT divided by NF log again product of this concentration, product of concentration we can tell, product of concentration of products. Suppose here X and Y, two products were there. Then what was the concentration of X? What was the concentration of Y? Then that multiplication you can tell. X multiplication of X into Y, that is the product also you can tell. Product of concentration of concentration, product concentration you can tell. Product concentration you have to write upside down, you should write reactant concentration, product divided by reactant, just like what I discussed in anode case. Product upside, concentration of products upside means X into Y, and what was the power that you have to write? X power small x was there, then write upside. Y power small y was there, you write upside. X power x, y power y divided by A power x, B power b. A power A, B power B. And all this concentration you write in big bracket. All, upside also, down also, every time. Actually that is called molar concentration, means molar concentration of products divided by molar concentrations of reactants. With power you have to write X power X, Y into Y power Y, means molar concentration of X into molar concentration of Y divided by molar concentration of A into molar concentration of B. Then same way you can write for all this value, R, T and F value. Then again you will get same things. E cell is equal to a standard E cell, its value is fixed. For any electrode, for any cell, its value is fixed. Then E cell is equal to a standard E cell minus 0.0591 divided by N log, again molar concentration of products divided by molar concentration of reactants. Then molar concentration of pure solid, you know, I already discussed. for pure solids, pure liquids and gases at 1 atmospheric pressure are put equal to 1. You remember, for at 1 atmospheric pressure, you remember, molar concentration of pure solid, all are pure liquid is also pure, not any ordinary liquid, mixing, nothing should be there, pure liquid, and gases also like H2Cl2, O2 at 1 atmospheric pressure are put equal to 1. Correct? Generally, product will be some in this in cell reaction, product will on cathode it will solidify, means it will convert to metal. Then for that you should write 1. For the metal always you write 1. Correct? If concentration, given concentration is there, that value you have to write. All pure, I told you, for pure solid, pure liquid and gases at 1 atmospheric pressure, it is equal to molar concentration value is equal to 1. And now I am stopping only here. Thank you. Next class again I will continue. Many terms are remaining. Thank you.